You have your next chapter, that is chapter 2, inverse trigonometric functions. This is already based on the previous chapter also. You have learnt about inverse and also functions. Here trigonometrics is a bit extra, and based on the trigonometric functions we are going on getting how we are going to get the inverse of that trigonometric function. For that we need to know what we have learned last year about the domain and the range of the trigonometric functions. So let us do that first. So first we have the sine function. Sine function. It has the domain from the set of real numbers and the range is from -1 to 1. That is, it can have the values only from -1 to 1 and or in between that only. So cosine is also the same. For cosine it comes to be r to -1 to 1. So the next one we have, that is a trigonometric function, is first we have tangent. Tangent is sine divided by cos. Sine divided by cos. So when cos is 0, tangent function does not exist. So the set it comes to be from r minus the set of x, where x is equal to n pi by 2, n pi by 2, where n is odd integer. Okay, this is the one way of writing, or you can write it to be the set x for x is equal to 2n plus 1 or 2n minus 1 pi by 2, where n is an integer or n belongs to the set of integers. This is the domain. Or let me write this. This is a simpler one, I think. This you can understand, but this is more simpler one to write. So this comes to be this one. So it is r minus this set. This is the domain, and the range is the real numbers. It can cover all numbers there. After that you have cotangent. Cotangent. So you have the numbers r. Cotangent is the inverse of this, or not inverse, I mean the reciprocal of this. So it comes to be cos by sine. When sine is 0, this does not exist. So whenever it is 0, that means whenever x is n pi, where n belongs to an integer. So when sine n pi is 0, that is a general form, you know. So that case is excluded from this domain. Then it can take all the values in the set of real numbers. Next we have, we'll take the reciprocal of sine, that is cosec, cosecant. So when it is the reciprocal, the condition comes to be the same, because sine comes to the denominator. So whenever sine is 0, this does not exist. So it comes to be the same, that is x is equal to n pi, where n belongs to z, but the range doesn't come to be the same. The range is r minus the closed, not the closed interval, it's the open interval. It can include -1 and 1, right? So it comes to be the open interval -1 to 1, -1 to 1. That means that it includes all the real numbers, but doesn't include the numbers that are in between -1 and 1. So that is the range for the cosec function. Now we have the sec function. Sec function has cos in the denominator, so it should take the form of this. So it is r minus z. X is equal to 2n plus 1 or 2n minus 1 pi by 2, where n is an integer. So these numbers are excluded, and here you are going to get the same range, that is r minus the set, that is the interval form of the set that says it is -1 to 1, all the numbers that are included. Or in another form I can write it to be, it is from minus infinity to -1 union 1 to infinity. Okay, This is a union of these two sets. That means that only that minus 1 to 1 are the set of numbers that are not included in this. These two mean the same. These two mean the same. Okay. Now this lesson is all about inverse trigonometric functions. This was all about the domain and the range of the trigonometric functions. Now we have to find the inverse of that function. For the inverse of the function, we know that it should be invertible. Invertible means it should be 1 1 as well as onto. Okay, let us take every one of them and then just see how we can make it 1 1 and onto if it is not. Okay. First function is the sine function. Sine function is the simplest and it's called the fundamental one also. For that we need to know the graph of sine. How do we draw the graph of sine? Okay, so now you have, this is the y-axis and you have the x-axis. Okay, this is the point 0. Last year you have already learned how do you draw the sine graph. Characteristic sine graph is also called as a wave graph. Okay, so generally when it comes to the physics, this graph becomes very important. This is the characteristic wave graph. So this is also called as a sine graph, where it is at 0 at 0. So I can write this graph to be y is equal to sine x. So let me mark the points where it comes. So you have here pi by 2, here pi, then here 3 pi by 2 and here 2 pi. Similarly, you can also write it as minus pi by 2, minus pi, minus 3 pi by 2 and minus 2 pi. Still this graph continues, so on here both the sides. I have just taken this much part of that. Okay, so now we need to think about the inverse of the sine function. That means if I need to draw the graph of the inverse function, it should be just interchanging the x and the y axis. That is, if I write y is equal to sine inverse x, it directly means that x is equal to sine y. I'll just tell how it is like that. So if I tell f of x is equal to y, f of x is equal to y, we found out by finding the inverse and all. So x is equal to f inverse of y. That was the thing we got while we are doing the finding the inverse and then telling f dot f of x is f dot f inverse is identity function. There here you are going to get the similarly that what you are going to use here. First you have sine x is equal to sine y. That directly means that y is equal to sine inverse x. So I need to just interchange the graphs of this is the y-axis, this is the x-axis. If I just interchange the x and y-axis, you get the graph for the sine inverse x. Okay, so but in sine inverse x, you find out that this function is not 1 1 and onto. Not 1 1 and onto. What does it mean? See, you find that the range of this function is only from minus 1 to 1. Okay, the range of this function is minus 1 to 1, but the domain of this function comes to be R. Okay, so just when you find out here, you can see that same amount of values are repeated again and again. The amount of values that come under this part is again repeated here also. That's what you find in the sine graph. So you can just tell that it cannot be 1 1 here, because you have a point, maximum point, that is 1 here, that is coming to this both these points, right? So if I give sine inverse of 1, what should I write? Should I write pi by 2 or should I write minus 3 pi by 2? Both of them mean the same. Both of them have sine of minus 3 pi by 2 and sine of pi by 2 come to be 1 only. So in such a case, the problem arises. So for that, we are going to use the principal value branch. What is the principal value branch? It means that we are just going to restrict our values only to a certain thing. So if I take the value, we should take only some values such that it doesn't repeat again. So if I have 1 point here and 1 point here that have the same value of sine x, so these 2 points cannot be included together. And here also we have 2 points that have the same value of y. or sin x value will be the same. In such a case, we can find that only this much part of this graph is not repeating. So for our convenience, we always take the one that is very near to the origin. So we find that both the parts are symmetric, and we just take it symmetrically about the origin. That is, from minus pi by 2 to pi by 2 is the region that we are restricting, not the whole R. So we need to write the sine inverse function should have a branch. So sine inverse x should have the domain and the range should be restricted. You have the range is only restricted, that is minus 1 to 1. So sin x can have values only from minus 1 to 1, and but you have the whole value of R. For one point you'll get so many values. So hence you are going to restrict this only to minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. So if you consider the unit circle, generally unit circle is easier to understand than the graph and all. You have the first quadrant, second, third and the fourth quadrant. Okay, in such a case we are just taking first and the fourth quadrant for the sine inverse function, sine function or the sine inverse function that we are considering here. Okay, that's what all about sine function and its inverse. So we understood that only this region comes under the principal value branch, and if I take any other value out of this, that should land up in one or the other values that belongs to this region. I have to take it such a manner that every value out of this should be there in this region. Okay, that's why we have taken minus pi by 2 to pi by 2. There might come a question, why can't I take from 0 to pi? Because it is repeating, that's obvious. Okay, next we'll move on to the cos function. Next you have the cos function. We have to decide what is the principal value branch for the cos function. See, we can also see that this is a graph which is displaced by an angle pi by 2, that's it. Because our graph of sine was here, now it comes here. That means it is moved pi by 2 from the initial. So it is very similar to the sine itself. So but when you find out here, in this sine function we took minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, the range minus pi by 2 to pi by 2. But can we take that here? So we'll see that here we have 2 points here that have the same value, and none of them have the negative value here. So we cannot take this one for the cos function or the cos inverse function. So now we need to find y is equal to cos inverse function. We know that its domain is minus 1 to 1 because the cos function can take only the values from the set minus 1 to 1. So it should be going to which set here now. For that we need to take the values that are very near to the 0. So here what we come to know here is we take the part that is from this y-axis to the pi, wherever this pi is there. From this you can understand that it covers all the values of cos x, that is both the positive as well as the negative values. As conventionally we always think positive, we take the positive part of that, so it comes to be 0 to pi. So it comes to be 0 to pi. So just we need to understand that doesn't mean that cos x and even though cos x and sin x have the same graphs, the principal value of branch of both of them are different. For the sine graph it was minus pi by 2 to pi by 2, but for the cos graph the range comes to be in between 0 to pi, so that we make it 1 1 and on 2 because it is however repeating. You can understand by it was the same graph, right? Okay, next we'll move on to the cot and the tan functions simultaneously. Now it comes to the tan and the cot function. We need to take care that we are only bothered about the changing the domain because it is repeating again and again and not the range. Okay, that's the thing what you need to know here also. So for this we need to make the inverse of those functions. So the domain in both the cases comes to be r itself. For the inverse functions, say tan inverse and cot inverse in this case. So we have in both of them the domain is r itself. So it comes to be from r to something else that we need to find out now. Okay, by seeing this graph we can find out that it is repeating again and again. Here we find the shape of this graph again and again. So we need to relate it to something. So because tan has sine in its numerator, tan is equal to sin x divided by cos x. Okay, say x, I'll put as one of things. You have sine in the numerator. Therefore, the principal value of branch of this is very similar to sin x. Okay. So in such a case, it needs to be from minus pi by 2 to pi by 2. Because it is similar, I just take the principal value branch of sine inverse function. So we have this thing. But we find out that at minus pi by 2 and pi by 2, it is not defined because tan function becomes infinity in such a case. So it cannot be defined in such a case. Therefore, we are excluding those two values and we are writing it to be minus pi by 2 to pi by 2 with open interval. That means that it is not included. Both of them are not included. Only the numbers that come in between that are included. That's it. So we are going to take this is the principal value branch. Okay. And we are not bothered about this in this chapter. We are bothered only about this part. Okay, when you are asked to find the tan inverse of any function, it always comes under this only. It cannot come under some 3 pi by 2 and all. Okay, that's the thing why we are choosing the principal value branch. Okay, now we have the cot inverse function. Cot inverse function we have from set R, a set of real numbers, to something else. So, but here we find out that this is not going to be working out. And also cot inverse, cot means cot x is equal to cos x by sin x. So since cos x is in the numerator, it is going to better work out with the principal value branch of cos. So principal value branch of cos was 0 to pi with the closed interval. That means 0 and pi were included. So here we have 0. At 0, this cot becomes infinity. Therefore, cot inverse cannot be defined in such a case. And also we have that such cases, this function is not defined also, because those are not included in such a case. So we have only 0 to pi that can be considered as a principal value branch, while 0 and pi are excluded. And only the numbers that come in between, that you can see the number values that come along this graph that represent the cot function. Okay, next we'll move on to the cosec and sec. Next you have the cosec and the sec function. In the cosec you have it is 1 by sine, right? So it is going to be very similar to the sine function. And you have the sec that is 1 by cos, that is going to be very similar to the cos function. That is the thing, easier way to remember it. So now you have the cos function. Cos function, you will have a graph that is like this. So it is not going to touch the graph because it cannot have the values. It cannot have the values in between this range, that is from -1 to 1, and all of the values can be included in that. So you need to consider both positive and negative values while taking the principal value branch. In the tan and cot, you had both the values in between the dotted lines only. You had the dotted lines like this in the tan and cot graph, and in between that you had both positive as well as negative values that the tan or cot that could take. But in this case you can find out that only this curve takes only positive and this part of the curve takes only negative. That means that you need to cut two parts and just join them. So by a clue, when however this is going to be the same, right? it is going to be r minus 1 to 1 is the domain for the cosec inverse function. And what is going to be its range? It is going to be similar to sine function. Sine function was minus pi by 2 to pi by 2, minus pi by 2 to pi by 2. Let us mark it in the here. So it is coming to be like this, here and here. In such a case, you can find out that at 0 cosec has no value, or it is not defined over there. Here it had to be r minus x when x is equal to 2n pi. Okay, and similarly it was r minus set x for x is equal to 2n plus 1 pi by 2. Okay, this was the thing. So those exceptions should be shown here also, because those exceptions could not define cosec functions. So cosec 0 was not defined at all. So in such a case, we cannot define cosec inverse 0 also. That's why. So we are going to have minus pi by 2 to pi by 2. In tan function, there was a problem with the minus pi by 2 and pi by 2. But in this case, there is a problem with 0. So how do we write that? So it comes to be the same thing, that is minus pi by 2 to pi by 2. This was the function that we took for a sine, and there was an exception. This exception comes to be 0 in such a case. So better to take it this one. Even this is the branch, if I take this in between these two lines, or if I take in between these two, this also becomes a branch, but it's better to take towards the origin only. So this comes to be the principal value branch of cosec inverse function. So now we have the sec inverse function. Sec inverse function, you have so many values, right? Just like cosec inverse function. So each thing will have again and again the repeating graphs. So we have from r minus set minus 1 to 1. So from here it is going to be defined. So if I need to define, I need to take some values which is positive as well as negative. So because it is sec, I have a thing that I know that it is going to be very similar to the cos, the principal value branch of the cosec inverse. So it was 0 to pi for the cos inverse. So now here you have the sec inverse. For sec inverse, it is just 1 by, right? No, cos was 1 by. So sec inverse is how we are going to get, we should see. So it had 0 to pi. This is pi, right? This is pi by 2. So we need to take these two lines, this one and this one. This area comes to be the principal value branch. We have the negative values here and we have the positive values here. With 0 and minus, no, not 0 is not there. You have 1 and minus 1 in both the cases, that is the maximum value. So it should be having, that is 0 to pi. So first we found out that these numbers were not defined for the sec function. How can it be defined for the sec inverse function? So in such a case, we need to remove that pi by 2 also that is present over there. We need to remove that pi by 2. So this comes to be the principal value branch of the sec inverse function. So what is the easier way to find out the value of a function, inverse function, when it is given? Okay, for that we need to use the unit circle. What is a unit circle? Is generally a circle which has unit radius that is used for calculating, or just by geometry you can measure the value of a trigonometric function instead of just having that. So you have a 0 here, and this is 1. This is the unit circle. In the unit circle, we know that here all of them are positive. All are positive. Here cos and cos related things, that is sec and cot. Even tan is there, but we are considering tan here because even tan is present, but we are not considering that. Here we have sine, cosec and tan. Okay, So if you need positive as well as negative values for sine, cosec and tan, we are using this range. This is the first quadrant as well as the fourth quadrant. So for this, that is the cos, sec as well as cot, we are going to use the first as well as the second quadrant as a principal value branch. That is the easier way to remember, because this is 0. If you consider angles, what we have learned in last year, how we measured the angle, it's from 0 to pi like this, again to 2 pi and all like that. So this you need to consider to be minus pi by 2, that's it. And this is pi by 2, right? This was how you considered. So we'll have an example of how we might understand how it could be. So first question could be sine inverse of 1 by root 2. Okay, the first thing we need to see the sign. The sign of this is positive, so there is no problem. It is going to come in the first quadrant only. So we have 1 by root 2. So we need to find some number such that sine of that thing is equal to 1 by root 2. Sine of what is 1 by root 2? Sine of pi by 4 is 1 by root 2. Therefore, sine inverse of 1 by root 2 comes to be pi by 4. Okay? Yes. Now we'll move on to another question. So we'll have some cot inverse minus 1 by root 3. Cot inverse minus 1 by root 3. We find that this is a negative sign. There is going to be a negative sign. That means it is not going to come in the first quadrant, because cos is in this group. Cos comes in this group. We need to consider the second quadrant. Okay, not the fourth quadrant. Even fourth quadrant is cot is negative, but here we are considering only the second quadrant. Okay, for that we must know that cot of pi minus theta is equal to minus cot theta. Minus cot theta. Okay, this is the thing that we need to see here. So when we have 1 by root 3, 1 by root 3 comes to be, so we need to find some value for which cot of that value is 1 by root 3. Just by our knowledge, we know that for pi by 3, it comes to be 1 by root 3. Yes? So, but there is a negative sign here. Because it is not going to be in the fourth quadrant, I cannot directly write it to be minus pi by 3 over there. Right? So because it is pi minus theta comes to be same thing. Okay? So we'll substitute this theta as pi by 3. Okay? We have cot of pi minus pi by 3 is equal to minus cot pi by 3. Right? Minus cot pi by 3. Minus cot pi by 3 was minus 1 by root 3. That was the value we had here. So what is the value of this theta? We need to find out. This theta is pi minus pi by 3. That is 2 pi by 3. Therefore, the value of this cot inverse function comes to be 2 pi by 3. 2 pi by 3. Okay? So this is it for the first exercise. So we'll go to the first exercise and then go on to the other properties and identities or so many for the inverse trigonometric functions. Okay, now I'm going to start with exercise 2.1. I have written the first 5 questions. Okay, the later ones are similar, so I'll do it once then and then the next one. So the first question is sine inverse minus 1 by root 2. So we know that sine of minus theta is minus sine theta. Okay, sine of minus theta is minus sine theta. Therefore, if I substitute half in this case, I should substitute half. Sine theta is equal to half. Okay, so what will be the sine inverse of this function? So it is for some sine theta that is negative. Okay, minus, so half is equal to minus sine theta. Minus sine theta. Okay, that much you have. So in such a case you can find that the positive theta for which sine of minus theta is equal to minus sine theta, that theta comes to be Sin theta is equal to half in such a case, and theta is equal to, so we can find out that it is 30 degree. 30 degree comes to be pi by 6. Okay, pi by 6, but it has a minus sign, so we need to just put a minus sign and write it will be minus pi by 6 because it belongs to the fourth quadrant where it is negative. Sine, cosec and tan are negative in such a case. Okay, therefore you'll get a negative theta only for sine, cosec and tan inverse functions. So now we have cos inverse is equal to root 3 by 2. What is the meaning of that? So if you want to find some value of x for which cos inverse is root 3 by 2. Cos inverse of that function is root 3 by 2. Therefore root 3 by 2 is equal to cos of that function, that is root 3 by 2 is equal to cos x. So some value of x for which its cos is root 3 by 2. That comes to be again at pi by 6. Because it is positive, no need to worry, it comes in the first quadrant only. Just write it as it is. You have again the positive value here, positive only, therefore it comes in the first quadrant. So cosec inverse of 2 means sine theta is equal to reciprocal of this, that is 1 by 2. Again it comes to be pi by 6. Because there is no negative sign, it is going to be pi by 6 itself. Next you have tan inverse minus root 3. Since it is a tan, it comes here in the fourth quadrant. So I can first write a negative sign, and I need to find some theta for which tan theta is equal to root 3. Tan theta is equal to root 3. Tan theta is equal to root 3 only for it is when it is 60 degree. 60 degree stands for pi by 3 minus pi by 3. Okay. Next you have cos inverse of minus half. Here we found out that for sine it was pi by 6. So for cos it comes to be pi by 3. Since there is a negative sign, it goes to second quadrant. Second quadrant, you always need to remember that cos of pi minus theta is equal to minus cos theta. So if I substitute theta to be pi by 3, when theta is equal to pi by 3, the right hand side becomes minus cos pi by 3. Cos pi by 3 is half, minus half you got. So pi minus theta is the required angle that we find out here. Okay, that is because it is negative, directly you cannot put it as negative in such a case. See, here you are going to get a positive value, that is pi minus pi by 3, that is 2 pi by 3. Okay, next we'll go on to the next 5 questions. Okay, now we have the 6th question. Now we are going to use, without using the unit circle, directly just by using our ring. So tan inverse of minus 1, because it is negative, it's going to be the fourth quadrant in the lower place. So it, first of all, you can write it a negative, 1 negative, and tan of some angle for it should be theta, it should be pi by 4. So it is minus pi by 4. Now you have sec inverse 2 by root 3, it is positive. So cos of some function is root 3 by 2. Only in such a case, sec of that function will be 2 by root 3. So if cos of that function is root 3 by 2, then it should be 30 degree. 30 degree stands for pi by 6. Pi by 6. Okay. Next you have cot inverse root 3. A cot function can be root 3 when it is 30 degree. 30 degree stands for the same thing, that is pi by 6. Because it is positive, no need to worry. Now we have cos inverse minus 1 by root 2. You have a cos and a negative, it always stands for a rotating thing. So when it is going to be a negative sign, you are going to get the second quadrant. For the second quadrant, always you need to take the angle pi minus theta. Theta is an angle for which you get the value 1 by root 2 should be the cos of that function. So pi minus theta, so you need to get 1 by root 2. In theta for such a case comes to be pi by 4 when it is 1 by root 2, right? So now you get pi minus pi by 4, that is 3 pi by 4. Okay, now you have cosec inverse minus root 2. So as it is a cosec inverse function, directly I can write it to be a negative sign here. Okay, then it is 1 by root 2. 1 by root is very similar to this one, because cos of cos pi by 4 is equal to sin pi by 4 is equal to 1 by root 2. So cosec of that also will be root 2. Okay, so it has to be pi by 4 minus pi by 4. Okay, next we'll move on to the next questions. Okay, next we have the 11th question. 11th question here is asked to evaluate the following things. So you have tan inverse 1, cos inverse minus 1 by 2 and this much. So tan inverse 1 is pi by 4, that was direct, and you have cos inverse minus half. So when it comes to the cos inverse, sec inverse and cot inverse, you are going to take pi minus theta values. Theta values is such that it should be 1 by 2, right? So it should be pi minus pi by 3. I'll write that itself here, pi minus pi by 3. That has to be coming here. Then you have 1 minus half, so it comes to be minus pi by 6 because it is 30 degree. Okay, because this was standing for the cos and this was for sine. Okay, now you have pi plus, these two are the positive values, so pi plus pi by 4 is 5 pi by 4. Then you have two negative values, that is pi by 3 and pi by 6, that is minus pi by 2. Okay, so what do you get here? We'll take the LCM. It comes to be 4 and pi is common outside, so you get 5 minus 2, that is 3 pi by 4. 3 pi by 4 is the value that you are going to calculate in this. Okay, the next, that is a 12th question. 12th question has, you have cos inverse 1 by 2 plus 2 times sin inverse 1 by 2. 2 times sin inverse 1 by 2. Cos inverse 1 by 2 was directly pi by 3, not pi minus pi by 3. So it is pi by 3, and 2 times sin inverse 1 by 2 was pi by 6, because it is not negative, it however positive. So it is pi by 6. Now you get pi by 3 here when you get cancelled 2. So 2 pi by 3 and pi by 3, you get 2 pi by 3 as an answer. Okay, now we have the multiple choice questions. That is the 13th question. 13th question says you have sin inverse x is equal to y. So where does y belong to? You need to just tell where does y belong to. So the principal value branch of this says that the range of the sin inverse function always has to be from minus pi by 2 to pi by 2. Therefore y should be always between minus pi by 2 to pi by 2. This is the principal value branch of that. That is the question, but it is not given as it is that it is the principal value branch. You are just asked to write where does y belong to. Okay, now we have the 14th question. The 14th question you have is, you are asked to again find the value of something. Okay, the value of that is tan inverse root 3 minus sec inverse minus 1 minus root 2, not root 2, 2 minus 2. The question is tan inverse root 3 minus sec inverse minus 2. So how do you need to calculate this? This is however positive, it comes in the first quadrant. So whatever tan value you get here, you get that is 60 degrees. 60 degrees stands for pi by 3, and you have one minus sign. So it is a negative sign, so I need to do it to be pi minus something. Pi minus something. So the value for which sec theta comes to be 2 or cos theta comes to be 1 by 2 is 60 degrees. 60 degrees stands for pi by 3. So this is pi by 3. Therefore it is pi minus pi by 3 is 2 pi by 3. Therefore it is pi by 3 minus 2 pi by 3. That comes to be minus pi by 3. That stands for the option B. Option B. Okay, I didn't tell which was option here. The option there was also B. Okay. That's all for today. Next, we are going to learn about properties and so many identities that you can use for solving and proving some number of statements that are given. So you get to prove that statements in the next class, and you are also going to get number of identities that are going to be proved. Okay, thank you.